You may have heard of the phrase the bell curve, and that generally deals with the normal distribution. It looks like this, which is a bit like a bell, and there are a few things worth keeping in mind with the normal distribution. First of all, it's a continuous distribution. And what happens with a continuous distribution is the probability that x equals any given value is 0. What we actually talk about with the normal distribution is the probability that a value will fall in certain ranges or something like that. So you'll find generally we're going to be looking at the probability that x is between two values. Something else about the normal curve that you won't find generally in any other distribution is it has no minimum or maximum value, which means the minimum value of the normal curve is negative infinity and the maximum is infinity. Even if we're dealing with a system, for example, Victorian study scores that might be between 0 and 100 or this sort of thing, you will still consider in your questions that the possible outcomes go from negative infinity to positive infinity. Now, something else about the normal distribution is it really puts into context the idea of standard deviation. So what we're going to do is we're going to have a look at this in a little bit more detail. So here I've got my symmetrical bell curve. You can see it's symmetrical, and the middle point here is the mean, and we're just going to write in there that that's the mean, which we use mu for the mean. Now, if we were going to make an approximation between the mean and the first standard deviation, whatever that distance is, and I'm going to draw the other standard deviation, one below and one above, and you'll notice they're exactly symmetrical, we would expect to get around 68% of our data between the mean and one standard deviation below to one standard deviation above. So if we have a system where our results are very spread out, then we would expect to have a large standard deviation, but still 68% approximately of our data will fall within one standard deviation of the mean. If I now look within two standard deviations of the mean, we have another similar case. And within two standard deviations of the mean, we expect approximately 95% of all our data to fall in there. And thirdly, within three standard deviations of the mean, so from here to here, we expect 99.7% of our data. So I'm going to write here mean minus 3 standard deviations, mean plus 3 standard deviations. And we're going to have a look at what these actually mean as well. So our normal distribution, our curve, is stretched out like this or squashed up like this according to how spread out our data is. But regardless of that, within one standard deviation, you'll always have about 68% of the data, and within two, always about 95%, and so on. So for example, if we were looking at a certain system, and we also assume that with the normal distribution, we have an infinite number of points. If we were looking at a normal system, let's say we're talking about people's intelligence scales or IQs, you might find data that tells you the IQ mean is designed to be 100 and the standard deviation is designed to be 15 points. So if I was going to fill this bell curve out with that information, my mean here is 100 and plus 1 standard deviation would mean I'm talking about an IQ of 115, plus 2 would be 130, plus 3 would be 145, and so on. Likewise, minus 1 standard deviation would give me an IQ score of 85, then as we go down 70 and 55. And what that means is by design, we expect 68% of people to have an IQ between 85 and 115. Put another way, in a probability context, if I chose someone at random, I would expect them to have a 68% chance of having an IQ between 85 and 115. Now, because these intervals are regularly placed and they're symmetrical, we can also work out the number of people we would expect to have, for example, between here and here, or even here and here, and so on. Remember, the middle is the mean, and for the normal distribution, it's also the median and the mode, which means 50% of my data is to the right and 50% will also be to the left. And finally, I'd like to introduce you to the standard normal distribution curve, and that counts how many standard deviations we are away from the mean. We generally call that Z. And so here at this point, I would have a Z score of -3. That's sometimes also called a standardized score. At this point, I would have a Z of -2. The next line, I'd have -1. And the mean of the standard normal curve is 0. The standard deviation of the standard normal curve is 1. So when we need to compare two systems, we will use the standard normal curve to compare systems by matching up our standard values. And you can see that these will line up, as expected, a certain number of standard deviations away. So during this unit, we'll be looking at the normal distribution. Remember, it's symmetrical, and we always look at ranges, not single points. The standard deviation is given as a place where approximately 68% of data lies between -1 and +1 standard deviations, or 1 standard deviation away from the mean. Approximately 95% of data lies 2 standard deviations within 2 standard deviations of the mean, and approximately 99.7% of data lies within 3 standard deviations of the mean. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.